Hello everyone, welcome back to my channel once again. So in this video we are going to understand how the occurrence of metals are there, right? So and this is the last part of this lesson. Okay, occurrence of metals, as we know that for metals the major source is our earth crust, right? And the another one will be the sea water, where you can get the metals in the form of soluble salts. For example, we have here NaCl and the second one will be magnesium chloride. Okay, NaCl and magnesium chloride. Now, why we are talking about these two again, right? So, when these elements, okay, when these two elements or many other elements or compounds, found naturally, okay, found naturally in the earth crust, that time they are said to be minerals. That time they are said to be minerals. Okay, when these elements or compounds naturally found in the earth crust, that time they are said to be minerals. Okay, but the twist is here, when in these minerals, okay, by taking the example of NaCl only, okay, only one particular metal is, okay, only one particular metal is high, it is present in the high concentration. For example, this sodium, suppose it is in 80% in the sodium chloride and remaining will be 20%, that is a chlorine. So you can extract or remove, okay, you can extract or remove from this sodium chloride, you can remove sodium only alone. Okay, you can remove this, you can do this. So that time, whenever from the minerals only a particular metal can be extracted, that time that mineral becomes ore. Understood? That time that mineral becomes ore. Okay, so I told you that we can extract, yes, extract any metal from the minerals. Fine. So we have here the new topic, that is extraction of metals. But wait, we have some methods, some rules to follow that extraction of metals. So first rule is we have to follow reactivity series. Okay, reactivity series of metals. So from that we have three types of metals. First one will be highly reactive, then secondly moderately reactive, and third will be least one. So let's see one by one. So highly reactive one, which are those? So potassium, yes, potassium, then sodium, calcium, magnesium and aluminum, these are the highly reactive. Then moderately reactive, zinc, iron, lead and Sn. Then least one, least reactive, gold, that is Au, Ag, silver, platinum and copper. Okay, so those who are at the top of this series, that is highly reactive elements, they don't found in the nature in free states. Okay, they does not found in the free state. But those who are in the middle one, that is moderately in the activity series, okay, they are moderately reactive and they are found in the earth crust mainly as oxides, then sulfides or carbonates. Okay, but these one at the least reactive metals or elements which are at the bottom of the activity series, they are oftenly found in free state. Okay, they found in free state. So from this, and sometimes this copper and silver found in the combined state as sulfide or oxides. Okay, so from this you can understand that how metal is extracted from its ore. Okay, from the reactivity series. Okay, so you will find that the ores of many metals found in the form of oxides. Okay, why? because oxygen is present in the nature in the abundant amount. That's why many of the ores you will say that they are in the form of oxides. Okay, so on the basis of reactivity, we have, there are some methods. Okay, there are some methods to extract, how to do this extraction of the metals from the minerals. So here you can see, for the metals of high reactivity there is a method, that is electrolysis of molten ore, then you will get a pure metal. Then for the medium reactivity, there are, we have to do first of all the carbonate ore. If you take the carbonate ore, okay, carbonate form of the ore, then you have to do the calcination and then go to the next form, that is again you have to do the oxide of the metal, then reduction to the purification of metal. This is the process. Then if you take the sulfide form of the ore, then you have to do the roasting method and then go for the next method. Then but when you have the low reactivity metals, then you have to go follow this method, that is sulfide ore, then roasting, then metal, then refining. Okay, but here one more twist is that these ores, yes, just I told you, they are getting, we are getting them from the earth crust. So they are mined from the earth, are usually contaminated or mixed with the some type of not some type, large amount of impurities. Okay, large amount of impurities. So they are not in the pure form. So what are that impurities? Sometimes soil, sand, okay, pebbles. So these impurities are there and togetherly we say them gangue. Okay, togetherly we say them gangue. So these impurity we have to remove that before doing the concentration of ore. Okay, before doing the concentration of the ore we have to remove that. So we can enrich the ore. Enrich means what? You are just enriching. You are putting the whatever the amount of the metal is there in the pure form. So that is the process for enriching of ores. Okay, enriching of ores. So for that, first of all you have to remove these impurities, which is very important step. So the processes used for removing the gangue from the ore are based on the differences between the physical and chemical properties of the gangue. And the ore and the ore, different separation techniques are accordingly employed. According to the physical and chemical properties of this gangue, okay, methods are different for the removing these impurities. So now let's understand about the first topic, subtopic under this, that is extracting metals where they are having, that is the least reactive one. So least reactive one, they are metals in the activity series which are very unreactive or least reactive. The oxides of these metals can be reduced to metals by heating alone. We have to just heat them. For example, okay, for the least one I am writing here, least reactive. Okay, so the example is mercury. Okay, we have here HgS, mercuric sulfide. Okay, we have to just heat it, or we can say it is as example, this is example of cinnabar. Okay, it is in the form of solid, plus we are heating it in the form of oxygen. In the presence of oxygen, 3 molecules of oxygen and heat. Okay, so what you are getting? You are getting HgO oxide form of mercury, then 2 sulfur dioxide, which is in the gas form. So again you have to do the double heating for this. Yes, here you are not getting only the mercury, you got here the oxide one. Again heat this and you are getting your 2 molecules of mercury, which is in the liquid form. This is the only method which is in metal which is in the liquid form. Okay, so what you have done here for the least reactive one, that is not hemoglobin, this one mercury. Okay, HgS, we are balancing this one, 2 HgS plus 3 O2 gas, which gives rise to 2 mercuric oxide plus 2 SO2 gas. But again you have to do the double heating here, then you will get the pure form of the metal, that is mercury. So let's start with the second one, that is moderately reactive. Moderately reactive metals, we are using here two types of methods, that is either roasting. Okay, when you take the sulfide form of the metals or ores, you have to follow with the roasting method. If you take the carbonate, you have to follow with the calcination method. Okay, this is for the carbonates. So for the moderately one, we are taking the example of ZnS, zinc sulfide. So first, as we are using sulfide one, we will follow the roasting method. So roasting method is what? Roasting method is when you heat the sulfide in the presence of oxygen. Okay. So I am writing here ZnS solid form plus 3 molecules of oxygen which is in the gaseous form. You are heating this and you got the ZnO plus 2SO2 gas. Okay, so this is the calcination. When the zinc sulfide or the sulfides are heating in the presence of oxygen, okay, you are getting the oxides, that is the roasting method. Now when you take the carbonates, okay, zinc carbonate, and you are heating this but in the absence of oxygen. Here, are you able to see here oxygen? No. So this is the calcination method, and again you are getting your zinc oxide plus, yes, carbon dioxide gas. Okay, but the metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. Again you have to use the reducing agent. For example, zinc oxide is heated, this one or this one. So zinc oxide again heated with the carbon, this act as here reducing agent. Okay, reducing agent. Reducing means what? Just removing the oxide from the, or oxygen from the oxide, zinc oxide. That is the reduction process, right? Then we will get the pure form of zinc plus carbon monoxide in the gaseous form. So you are already familiar with the process of oxidation and reduction, right? Which is explained in the first chapter. So obtaining metals from their compounds is also called a reduction process. So besides using carbon, okay, besides using carbon or to coke to reduce the metal oxides to metal, sometimes displacement reaction is also used. Okay, in between we just got a displacement reaction. Let's understand this. Okay, so the highly reactive metals such as sodium, calcium, aluminium are used as a reducing agent. Okay, are used as a reducing agent because they can displace of lower reactivity metals, okay, from their compounds. That's why we are using this high reactive one for removing low reactive ones. Okay, take the example of manganese oxide, MnO2, which is in the solid form, plus we are using here aluminium powder. Okay, then what we will get? We will get 3 molecules of manganese in the liquid form plus 2Al2O3 solid form plus heat, and this type of reaction, okay, exerts a lot of energy, and that's why this type of reactions are exothermic in nature. This type of reactions are exothermic in nature. So the amount of heat evolved is so large that metals are produced in the molten state. That's why we are getting here this manganese in the liquid form. So let's understand for the extraction of highly reactive one. Okay, how we can extract them? So as we know, the highly reactive one, that is sodium, magnesium, calcium, aluminium, they are not easily recovered or extracted from their ores by just heating. Yes, by just heating with the carbon. Okay, so how we can remove them? So we are using electrolytic reduction process for the extraction of these highly reactive metals. Why? Because these metals have more affinity, okay, more affinity towards oxygen than carbon. So these metals are obtained by electrolytic reduction, just I told. So how we can do that? So just by taking the example of sodium chloride, okay, when you dip in the electrolyte, we are getting the two ions, Na plus and Cl minus, right? These plus minus ions at cathode, okay, cathode which is negatively charged and anode which is positively charged. So it is the common sense that Na plus will attract to the cathode and Cl minus will attract to the anode because oppositely charged, right? So this we can write as Na plus, by releasing electron it will becomes Na, and Cl minus, okay, it will become Cl2 plus 2 electrons, accepting 2 electrons. Now why Cl2? Because chlorine is an chlorine is diatomic molecule, okay. Chlorine is a diatomic molecule. Diatomic means chlorine only becomes with the two atoms, okay, it becomes with the two atoms only. It is a diatomic molecule, so that's why it becomes Cl2 here, and for balancing we are writing 2 here, okay. So similarly, by using this electrolytic reduction, we can also obtain aluminium from aluminium oxide, okay. So this is the end of the lesson. Thanks for watching.